So now we take a look at the 1,2 addition of water to aldehydes and ketones. This is a reaction that's generally used to form hydrates from these carbonyls. And the overall reaction is that we start with a carbonyl, an aldehyde or ketone, and through the addition of water under either acidic or basic conditions, we form a hydrate. Now, this is one of those reactions that is really only useful under very, very specialized conditions. And what we mean by that is that in general, this reaction, the equilibrium strongly favors the starting materials. So unless we have a process that really, forces us toward product, this reaction is not always all that useful. Now we do have situations, especially in the case of other reactions, where we've seen the utility of this reaction. For example, if you recall the reaction of oxidizing a primary alcohol with Jones reagent, you may recall that this reaction first gives the aldehyde, and then that aldehyde oxidizes a second time to give the carboxylic acid. And so this is an example of a reaction where this hydrate formation actually plays a very prominent role, because this step in between the aldehyde and the carboxylic acid is the formation of the hydrate. And even though the equilibrium here is very poor, any of the hydrate that does form gets moved on to the product. And so Le Chatelier's principle, we're able to take advantage of this fact, and the hydrate does form. So again, it's one of those reactions that is, very specialized to certain situations, but can be very useful. How does it work mechanistically? Well, mechanistically, again, it's going to depend on whether we're under acidic or basic conditions. But in a lot of ways, the only difference in those two mechanisms is the order of the steps. So if we're under acidic conditions, as with most reactions of carbonyls under acidic conditions, the first thing we do is protonate the carbonyl. That activates the carbonyl. With water here, we don't have as strong of a nucleophile, and so we need to increase the electrophilicity of the carbonyl. We can then have water attack, electrons shift up onto the oxygen, and then we just lose a proton to get to our hydrate. Under basic conditions, and I should say the acidic conditions are what show up in the Jones oxidation, because that reaction is done with sulfuric acid. Under basic conditions, we don't need to activate the carbonyl. The hydroxide just attacks directly. And then that oxygen anion can pick up a proton from water to give us the same product.